Okay. This talk I will show some SparkR best practices for the R data scientist. So if you are R data scientist, maybe you give the smart choice to come this session. My name is Yan Bo Liang, an Partition Spark committer and a software engineer at Hortonworks. Our talk will first the introduction, and what is R and what is SparkR, and what is a typically data science workflow. And then we show some typically scenarios for data science problems and how to resolve these kinds of problems by SparkR and R. At last, we will show some feature direction for the SparkR community and for the users from the user's perspective. Okay, I think if you are a data scientist, you may be familiar with R. R is an open source, and a lot of universities have teach their students to using R, not only in computer science, also in a department like statistics or mathematics. And there are a lot of packages, nearly 10,000 packages you can use. And the most important feature for SparkR is the visualization. It's a fundamental human activity. A good visualization will show you things that you didn't expect or raise new questions about the data. But visualization don't need to scale particularly, since a very large data visualization you will not interpret anything from the very, very large data. You can't interpret it. But there are limitations for the single node R. It will need a lot of memory if your data set is very, very big. So it can handle very large scale data processing problems. So this is what SparkR, this is what Spark community will export the SparkR package. SparkR is actually is a front end for Apache Spark, and since Apache Spark is widely deployed cluster computing engine, so SparkR is one of the 4 language APIs for Spark. And Spark provides the distributed processing engine, and it also provides some fantastic functions like loading data from different data sources, such as you can load CSV, you can load Parquet, you can load the ORC file from HDFS, or you can directly load some files from S3 or database system. And a lot of third-party packages such as Spark HBase connector can be used to load HBase load HBase data. So it can be seen a centralized computing engine for the distributed environment. So I think the SparkR combines the advantage of both Spark and R. Let's have a look at the SparkR architecture. SparkR's architecture consists on mainly 2 components shown in the picture. One are 2 JVM bindings on the driver that allow R programs to submit jobs to a Spark cluster and support running R on the Spark executors. And the communication between the R and JVM is we use socket-based API. This is because most of the messages being passed are control message, not the data copy. So the cost of using socket as compared other in-progress communication methods is not very high. Okay, we have the basic tool for SparkR and R, and let's have a look at what a data science workflow usually looks like. First, you will import data into R from maybe all kinds of data sources. And then, after you imported data, it's a good idea is to tidy it. Because real-life data usually contains redundant columns or some missing value. You need to remove them. And once you have tidy data, first common steps is transform it with the operation like select, filter, arrange, drawing, or group by. It's more like the circle operations. Together, tidy and transforming are calling data wrangling. This is because getting your data in a form that is natural to use for you is just like a fact. Once you have tidy data with the variables you want to use, there are two main engines of knowledge generation, the visualization and the modeling. They have complementary strengths and weaknesses, so any real analysis will be iterate between the two steps. Okay, then actually we have talked to SparkR and R have both their advantage and disadvantage. So the best use way is to combine them. Another reason is SparkR can't cover all features from traditional R, since there are a lot of package has been developed in the R community. And another important thing is not every data set is very big. You need to handle a lot of media or small data set. And you encounter some problems when processing with single R. We will talk it later, how to accelerate your media or small data set processing with SparkR. Okay, this is the main content of the talk. We show three typically scenarios to using SparkR and R to accelerate your data science workflow. The first scenario is usually you import the data source. You will import large data source, large data from different data source. You will have table 1 or table B, maybe very, very large, and you will join them together and to generate a new table. And after that, you will do some basic operations on the data set. This is usually unfeasible to happen on a single node because your data set is very, very big. So we usually want to do these operations in the distributed environment. So SparkR is the best choice to handle this workflow. And after that, after select, after aggregate or simple, the data set will become smaller. We can collect the Spark data frame to the local data frame. Then you can use all your experience of single node R to process your data set, to model your data set. You can say this slash is some very, very basic data operations in single node R, but it also has very, very similar APIs or just the equals APIs for SparkR. So if you are familiar with R, it will be very smoothly transformation for you to use SparkR. And you can handle a very large data set using almost the same API. Let's show an example. The example is use the famous airline data set. You can say, first we read two tables of CSV format, and after that we have the two tables may be very, very large, and then we join them together to select some columns what we want to use. And during this, maybe some columns or maybe some rows contain some non-values, we need to remove them. We can use the drop.NA API to get the very we can say get the data what you really want. And someone will concern about Spark is a data distributed computation engine, but different API may have different efficiency. From this slide, we can show that almost the same, almost a different API, almost the behavior same. This example shows the runtime performance of running group by aggregation on a 10 million integer pairs on a single node in R or Python or Scala API. We can say that because all of the different API use the same backend execution engine, so the performance is almost as equal. Okay, after the data wrangling, users typically will aggregate or simple some data. This step will reduce the size. You can say SparkR provides a lot of APIs for simple, and you can also simple to a specific group. This is very useful for the machine learning, since the positive labels and the negative labels will unbalanced in almost all the case if your data comes from real life data. But there is a question: is that all of the data all of the scenarios we will simple, it will work well? If this, why we need to handle a large data set, where we need to train some models on the whole data set? We can take all the data simple and fit in a single node machine learning library. I think this have different usage. For some of the data, maybe simple will take a little effect of the last result, but for others, maybe not. We will show how to do the machine learning or how to build a model on the whole data set without simple later. Okay, after that, we can say we have collect the data frame, Spark data frame, to a local R data frame. So this is, I think, is one of the most useful scenarios for SparkR. And you can use all of the experience when using your native R. One issues between combining a whole pipeline using SparkR and R is the data transform between them. If you collect a medium-sized data frame to local and continue with the local R workflow, this is very useful use case. And the transform maybe not very frequently, but we also need to improve the performance. Currently, we have scenarios and have plan to make it more better, since a lot of users complain the performance is not good. If you have using this operations, you can feel the performance is not good. But maybe in Spark 2.3, it will become better. Okay, this is the first scenario. Let's look at the second one. It's partition and aggregate. It's useful for a number of statistic applications like the ensemble learning or parameter tuning. So in this case, usually user will typically have a particular function that need to be executed in parallel across different partitions of the input data set, and the result from each partition will be combined using an aggregate function. In Spark, we have provide UDF. In SparkR, we also provide some UDF functions like the dapply and apply. What the functions like, we can show a very simple example. you can say, originally we have 3 or 4 columns, and the aircraft type, the distance, the arrival delay, and the departure delay. We want to convert one of the columns to another kind of representation, such as from the minute to seconds. So we can use, this is not very easy to implement it in Scala or in Python, but for R, we can use this kind of RPI to do this. This is a dapply function. And another case is we will group the specific partitions and to generate a max value or mean value or sum value from this group. This is more or less the group by operations in Circle. And for example, we will statistic the max actual delay, a delay of a different distance. So we will group by the distance and to calculate the max actual delay in such kinds of functions. And in addition to the above UDF-based API, we found that for some use cases like parameter tuning, and the input dataset is small, but there are a number of parameters that need to be evaluated in parallel. To support such workflow, we provide a parallel execution API where we take in a local list, a function to be executed, and run the function for each element of the local list in one call of the cluster or one node in the cluster. We can say an example. For example, we will train a generalized linear model with the GLMNet package. This is very famous R functions in GLMNet package. Currently, you can say the code, we will train 6 models, since we can have 6 parent combinations. We will train 6 models. If we write the code like this, the whole code will run sequence in your single node. For example, if you train one model, you will take 1 minute. The whole process will take 6 minutes to finish. Can we use Spark to accelerate the whole process? Each input of the GLMNet algorithm is not big. Maybe it's small. It can fit into the memory of a single node. So we can show we use the SparkR apply function. The API is more or less like the apply function in R. You can say, I will first explain the whole process can be finished in 1 minute. Because if you have enough resource, the whole code will be run distributed across your cluster. If you have enough resource, for example, you have more than 6 containers, it can be run parallel. And each model still need 1 minute, but we can run them parallel. The whole process can finish in 1 minute. So this is what I want to explain. The SparkR can also accelerate some native R applications. And then we can choose the best model, the best coefficients, or the best parameters to use. And we use the AUC, is a matrix in machine learning, to evaluate which model is better. Okay. You can say the picture illustrates what is happened. And suppose we have 6 executors and 1 drivers, and the parameter combinations is 6. So in each executor, it will train 1 model according to the specific parameter combinations. And then we will collect the result back to driver. And what will back to return to the driver is the coefficients of the model and the AOC of the model. So we can run them parallel. And you can say the GRMNet is not a native package for R. It means if you install R on your local machine or on the whole cluster, it will not include this package. And we have a lot of such kinds of package. For example, I have shown in R community, we have almost 10,000 packages. And it's impossible to install all the packages on your each machine. So usually you will use, you will install the packages when you use it. So for these scenarios, it looks as very feasible to install the package because we start the job with the SparkR API. We don't know our jobs, our tasks scheduled to which executors. Usually you will mess with the IT or administrator of the cluster to deploy all this package on the cluster. And this will involve another problem. After you use this package, the package will still located at that machine. And another users will use the same package, but maybe different versions. So there may be conflict. What we can, how to resolve this problem is we have make virtual environment support for the Spark. This is I think it's a very important feature for make Spark in production. When you deploy Spark on Yarn, each Spark job will has its own library directory, which is bound to the executor's container. This is only this is only applicable to the Yarn deploy mode. And unnecessary third-party libraries will be installed into that directory. After the job exists, the directory will be deleted, and there is no environment pollution to other jobs. And which means if you use the GRMNet package, you can install it. And after your job finished, it will clean by the framework. You don't need to handle it by your hand. You can, let's say a very simple example. The first, we will download the package, and then we will add the package to the Spark distributed environment. Since Spark has a distributed cache. And we can say this is the example, updated example compared with the original one. You can say we add the line code at the start of the function. We first get the Spark files from the distributed cache. This code will be executed on each worker or executor. And then we have the package on each workers will install it. After that, we can use it. We can use it to train the model on the executor. At last, we don't need to write any code to remove them. Spark, the Yarn environment, will help us to remove them. So this is very, very feasible features for the SparkR jobs if you want to use third-party packages. Okay, let's show the third scenarios for SparkR can handle us, can help us. It's large-scale machine learning, just like what I mentioned. Some data we can sample them and put them to a local R data frame and start to train all kinds of machine learning model in single node, in all kinds of R packages. But maybe some requirements or some data set, the simple will lead our model accuracy. It will behave less. So in this scenario, we provide some distributed model training algorithms in SparkR. and the backend of these algorithms are MLlab. It's also distributed in the Spark. You can show this package. This is not a package on Spark. This is the top 20 R machine learning package. What I want to show this, why I want to show this package is because almost all these algorithms are implemented in SparkR currently, which means the most popular used machine learning algorithms are in SparkR, are in distributed mode. We can train a very large model on the Spark environment. You can show this slide is what we have exported by SparkR. This is until the Spark 2.1, and at Spark 2.2 we have more algorithms. So lots of the functions in the top 20 single node machine learning rank have corresponding scalable implementation in Spark. Yeah, we are still working on more algorithms here. So when you try to do some large-scale machine learning with SparkR, I think first you should ask yourself, do you really need to execute, to run your ML jobs on the whole data? If not, please first sample your data and then run your local R machine learning algorithms, since they have rich algorithms compared with the distributed one. But if it's really necessary to run some machine learning on the whole data set, you can try SparkR. And if there is no corresponding algorithms to satisfy your requirement, you need to first contribute some algorithms to MLlab, and then we can expose API for SparkR. Okay, let's show the examples. GLM is a very, very famous and very, very widely used models in data science or in statistics. And from our examples, we'll call GLM with a formula specifying the model variables. We specify the Gaussian family here to indicate that we want to perform linear regression. MLlab caches the input data frame and launch a serious Spark job to fit our models over the distributed data set. But we don't need to handle anything for MLlab, since if we run this line code, MLlab will do these things under the hood. We are interested in predicting airline arrival delay based on the flight departure delay, aircraft type, and the distance traveled. This is what the R formula means. If you are familiar with R, you can understand it very easily. And we have three features. One of the features is category type, and two features are continuous type. For continuous type, it's easy to handle. For category type, usually we need to do something like one-hot encoding. But in our API, we don't need to handle any of this. SparkR will directly call the underlying MLlab to handle this. So you don't need to do it manually. So SparkR now provides seamless integration of data frame with some common R model functions, make it simple for R users to take advantage of the distributed machine learning algorithms. You can say the output of the model is almost the same as R. What is the difference is the derivance wrangle is because it will status the media or the mediums of the whole residential. So if you make this statistic on a very large data set, it will be very, very slow. So you can say we will do that approximate statistic with relative error about 1%, about 1%, yeah. Okay, and the other kinds of summary is almost the same as R. So you can run, you can transform, you can migrate your existing R programs to SparkR if your can't scale, if your currently your program can't scale well. Okay, and last we'll say some feature directions about the SparkR community. The first priority thing is the collect or create data frame performance. Actually, the create data frame performance, we have resolved it, and the performance is good currently. Collect, we are still working on it, and maybe in the next release, we can solve it. And it will be very efficient at that time to make a data science pipeline combining SparkR and R. And another is more scalable machine learning libraries for SparkR, since R is usually used not only for machine learning, but also for some statistic. We have little statistic functions currently exposed as R. So we need to make to explore more. And another is better R formula support. You can say this slice. If we have read our machine learning algorithm with the R formula, it will make the thing very, very simple. We don't need to handle 100 encoder. We don't need to handle a bucket, and we don't need to handle a lot of things. We don't need to handle whether we will need to fit with intercept or not. So we should have better support, such as the feature interaction. Currently, we only support the double type. We don't support the feature interaction between string, category type, and numerical type. So we need to have a better support for R formula. And another important one is UDF performance improvement. Since UDF and parameter tuning it may be useful for your data set is not very, very big. So we still make some efforts to make it run fast. Okay, I think I finished my talk. Any questions? Okay, okay. A lady first. Okay, you can use the microphone.
You guys hear me? So when you're using SparkR through Livy, can you do the same thing where you're submitting the different libraries for R?
Could you pardon?
With Livy SparkR, you talked about the ability to not have to install all of the R libraries on each worker node.
Yeah.
Can you do the same thing that you were talking about doing in SparkR?
Yeah, we can. Currently, we can. This is what the virtual environment supports.
Okay.
Yeah, we have merged this feature in Spark 2.1. So if you can use HTTP 2.6, you can use it.
Okay, thanks.
Okay.
This is more of a, can you go back to your couple slides? Go back to your model there. Go to the coefficients you had there. The only one that I really see that's significant correlate is distance. So my question is, and this is a side question, why did you even take the other features? Because if you look on your intercepts delay, the p-value, the only one that's really significant is distance. Or I would call highly correlated with significance, right? I don't really see why you would even take departure delay. I get a little bit, but wing type, I think those are. I would throw those out personally.
Yeah, we can add more features. This is just examples.
Sure.
Yeah, and for SparkR users, you can directly use any vector types in the feature. If your data set is produced by some other engineers who are familiar with Scala, so for that time you don't need to list all of the feature names in the formula. Right. Yeah, it can be done.
I mean, I didn't see at any point where you actually did a correlation matrix pre this step that you'd actually pick which features you'd want to put into your model. That's one piece I'm seeing that but that's a side note. I am a data scientist, so we can talk later, really.
Okay. We can talk later. Okay.
have a quick question. I know in R we have different packages for us to build time series forecasting model. So in the SparkR, whether there is any equivalent libraries we can use to build ARIMA, this kind of a time series forecasting models.
Okay, this is a hard question. A lot of users has requirements to processing time series data on Spark, but I think until now we don't find any libraries to handle this very, very efficient. This is because usually the time series data is column-oriented, which means we usually store as a column is more better. But currently in Spark we didn't support it, but we have planned to support it. I think at that time maybe it's easier to handle some time series data distributed on Spark, and export the API for SparkR may be easy. Yeah. Okay.
So when you do a Spark data frame dot collect, right?
Yeah.
So it will give you the R data frame. That is not distributed, right? The R
Yeah,
data frame.
yeah,
That's
yeah.
what I wanted to. So when I perform the iterations and aggregations over that R data frame, it's not distributed, is it?
Yeah. I think currently I mentioned the bottleneck of collect is not because the collect happened in one machine, in single node. We suppose that the data you collect is not very, very big. This is a assumption. If your data is very, very big, you don't need you must not to collect that. I think currently the bottleneck is on our implementation. Just we use some very high level API and functions. We didn't use the very efficient APIs currently. Yeah.
Thank you.
Okay, I think time is due. So thanks everybody coming this session. Thanks.